there, it's Mrs. Lindquist. So today we're going to talk about solving trigonometric equations. So example 1 says use the unit circle to find the degree measure of the angles. So we're looking for angles whose sine value is -1/2. So remember, sine is our y value. So where are the y values going to be -1/2? Well, we're going to be going down 1/2 to get to this coordinate, and we're also going to be going down 1/2 to get to this coordinate. We're looking at these two locations right here on the unit circle. And it says find the degree measures of each angle. So we're going down -1/2 here, so our sine is -1/2, and we're also going down -1/2 over here. A little acronym for you to remember is all students take calculus. All students take calculus. And what this means is in quadrant 1, everything is positive. Sine, cosine, tangent, all your trig functions. In quadrant 2, only sine is positive because you're going up to get to the coordinates. In quadrant 3, only tangent is going to be positive. And in quadrant 4, only the cosine is going to be positive because you're going right to get to all of these locations right in this quadrant. What are the angle measures here? So we're looking for this angle measure right here, which would be 210 degrees, and we have 330 degrees. But remember, there are many angles that have this terminal location. If we add 360 degrees to this location, we're going to be back here again. So theta equals 210 degrees, plus or minus multiples of 360, so 360 degree n, and also 330 degrees. Plus or minus 360 degree n. So go ahead and pause the video and see if you can come up with example B. Well, let's think about cosine is our x. So where is x positive? X is going to be positive in quadrant 1. So let's just kind of write our all students take calculus. So we can see that cosine is going to be positive in quadrant 1 where everything is positive. It is also going to be positive in quadrant 4. So square root of 3/2, we want our x value to be the square root of 3/2. So that'll be this location right here. So we're going to be going to the right, square root of 3/2 at this terminal location, but also down here in quadrant 4. So where is the cosine of positive root 3/2? That would be at 30 degrees and 330 degrees. Remember, we have to include all of our coterminal angles. So we have not just 30 degrees, but we have to add in all of our multiples of 360 degrees. So plus 360 degree n. And then we also will have theta is equal to 330 degrees, plus or minus 360 degree n. So any multiple, you could add 360 or 360 times 2, 720. You're still going to end up at this same location right there. All right, so example 2 says use the unit circle to find radian measures of each of the angles. So where is cosine equal to 0? So remember, cosine is our x. So where is x equal to 0? Well, x is going to be equal to 0 up here at 90 degrees or 0, 1. And x is also going to be equal to 0 at the coordinates 0, -1. So we can see our x value is 0, our cosine value is 0 at both of these locations. They want us to find this angle in radians. So up here at the top, this would be 1/2 pi, and down here at the bottom would be 1.5 pi, or 3 pi divided by 2. So we have to write out all of our angle measures where we're going to have a cosine of 0. So theta equals pi/2 plus or minus, but instead of adding 360 degrees, remember we're in radian mode, so once around the circle would be adding 2 pi. So we're going to add multiples of 2 pi, so 2 pi n. So we could add 2 pi, we could add 2 pi times 2, we could add 4 pi, any multiple of 2 pi, so 2 pi, 4 pi, 6 pi, etc. And we also have to have 3 pi/2 and all of its coterminal angles. So both of those would be our solutions. All right, go ahead and pause the video and try out example B. You're looking for where the cosine is -√2/2. Remember, sine is our y coordinate. So where is our y value going to be -√2/2? It's going to be negative in the bottom two quadrants. Again, if you think of all students take calculus, sine is positive in quadrants 1 and 2, so it must be negative in 3 and 4. When we're going down root 2 over 2, we're going to be at a multiple of 45 degrees. So it would be these two locations right here. So you can kind of draw out your triangles. So we can see our sine value is negative root 2 divided by 2 over here. And it's also going to be negative root 2 over 2 at this location right here. So again, we are doing it in terms of radians. We think about our multiples of quarter pi. We have quarter pi, half pi, 3/4 pi, and then we have 5 pi over 4 over here, and 7 pi over 4 over here. So again, this is pi over 4, 2 pi over 4, which is our half pi, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 is 3/2 pi, and 7 pi over 4. So we're going to have theta equals 5 pi over 4 plus or minus 2 pi n, and also 7 pi over 4 plus or minus 2 pi n. Okay, so in example 3, it says solve each equation for theta between 0 and 2 pi. So as soon as they say that, we know that we are in radian mode. If it says between 0 and 360 degrees, we would know we were in degree mode. So our answer should be given in radian. So we're going to solve this equation for sine theta. So we need to get sine theta on one side. So we'll subtract 3 sine theta on both sides. When we do that, it's going to cancel out. We'll have 1 is equal to negative 2 sine theta. And to finish solving for sine theta, we'll divide both sides by negative 2. So we are looking for where sine of theta is equal to negative 1/2. So go ahead and look at your unit circle. Where is the sign negative? Well, we're going down negative 1/2 at this location here, and then also at this location over here. So they want our angles in radian measure. So if you recall, this is 7 pi over 6. Again, you could think about this as being your pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6 pi over 6, 7 pi over 6, 8, 9, 10, and your last one is 11 pi over 6. So for this problem, we're looking at angle measures between 0 and 2 pi. Well, we just got in both of the angle measures between 0 and 2 pi, because remember here is 2 pi. So theta is going to be 7 pi over 6 and 11 pi over 6. We don't really need to do plus or minus multiples of 2 pi n because it says between 0 and 2 pi. If it said all theta, we would have to include that. Okay, well that's the end of part 1. I'll catch you guys for part 2 in a few moments.